Hi guys, welcome back to my channel. Let's start today's topic. I've already discussed the shape of the molecule in my previous video, and we have already discussed the shape of tetrahedral complex, trigonal planar complex, trigonal pyramidal complex, and non-linear shape. Now, see that when we have a double bond or a triple bond, please try to ignore the double bond and a triple bond when you consider the shape of the molecule. So the double bond and a triple bond will not help to figure out the shape of the molecule. So try to ignore the double bond and triple bond. So we didn't get it. Okay. Now look at that. Carbon with oxygen. Look, carbon has 4 electrons in the valence shell. It has 4 electrons. 1, 2, 3, and 4. Okay. And oxygen has 6 valence electrons. For oxygen to get the 8 electron in the outermost shell, each oxygen atom share 2 electrons. Look at the 2 electron. So this oxygen, it has 6 electron. 1, 2, 3, 4, 5, 6. So it will share 2 electron with the carbon. And one more oxygen atom. Look at that. One more oxygen atom. 1, 2, dot and cross. 1, 2, 3, 4, 5, 6. So in most of the cases, when oxygen combines with the carbon, oxygen either form a triple bond or a double bond, not a single bond. That is not possible, guys. This is not a right structure. Oxygen with a carbon, there will be no single bond. It is always a double bond or triple bond, like in case of carbon monoxide. Now look at that. So oxygen, look at the sharing. Oxygen form double bond with carbon. Each carbon share 2 electron because carbon has 4 electron in its valence shell. So oxygen form a double bond with the carbon. This is an example of carbon dioxide. That's the carbon dioxide, CO2. So in CO2, each oxygen form a double bond with the carbon. Now, I told you, note, please note it down, that one. Ignore double and triple bonds when we draw the shape of the molecule. When we work out the bond angle of any compound, you have to ignore the double bond, like pi bond. Just ignore it. When you ignore it, how the molecule looks to you. There is a double bond, but just ignore when you work out the shape of the compound. So it looks like a linear compound. Yeah, non-linear because the water molecule has 2 lone pairs. So there is no lone pair bond pair repulsion. Do a double bond create any lone pair bond pair repulsion? No repulsion of these electrons, of these bonded pair of electrons. So no repulsion. One more question will come in the mind. Can a double bond or a triple bond affect the shape of the molecule? No. It may affect the bond length, but we are not discussing the bond length. Yeah, but the bond angle is fine. No problem created with the pi bond or with the double bond and triple bond or on the shape of the molecule. So just ignore the double bond and a triple bond. Now look at that. It look linear to me. Linear. What's the bond angle? 180 degrees. Look at that. So what is the example of a linear compound? Carbon dioxide, CO2. What's the bond angle? What's the shape? shape of CO2, linear, perfect linear. And what's the bond angle? BA, bond angle 180. Now, can we do the triple bonded compound? Yes, we can do the triple bonded compound. So double bonded compound, we have done it. Now triple bonded compound. Guys, any example for triple bonded compound? I want to do one more example for double bonded compound. Yeah, that's I have seen in some past paper. Ethene. Look at the ethene molecule. C2H4. Not ethane, ethene. So that's alkene. Alkene is a hydrocarbon in which there will be at least carbon-carbon double bond. I will teach you guys when I will make videos on organic chemistry. Look at the structure. That's the ethene. There is a double bond between carbon and carbon. Okay. Now, I told you just ignore. So we will do what's the shape and bond angle of question. What's the question? What is the shape and bond angle of first A, we have done carbon dioxide just now, B, ethene, C, hydrogen cyanide, HCN. Now look at the ethene. Look at each carbon. Each carbon make 4 bond, 1, 2, 3, 4. And I told you, ignore pi bond or a double bond, just ignore it. So each carbon make 3 bonded pair of electron, 3 bond and no lone pair. Is that okay? It has 3 bonded pair of electron and a no lone pair. Look, each ethene molecule has 3 bonded pair of electron and no lone pair. I know there's a double bond. It is a planar molecule. So we have done like a BF3. We have done the shape of the BF3. Boron has 3 valence electron and it can form 3 bonds. So in case of boron, we have seen 3 bonded pair of electron and no lone pair. Very similar condition. 3 bonded pair of electron and no lone pair. So the shape of the molecule is trigonal planar and the bond angle is 180. Look at that. The shape of the molecule is trigonal planar and the bond angle is 120 degree. 120. Okay, each carbon, we are talking about the each carbon, 120. And what's the bond angle? 120. Shape of the molecule, shape of C2H4 is trigonal planar. Trigonal planar, and the bond angle is 120. Planar. I want to discuss one more, hydrogen cyanide. Look at the hydrogen cyanide. Okay, can I rub the board? Look at the hydrogen cyanide. What's the shape? Hydrogen cyanide, HCN. Carbon and nitrogen. Nitrogen has 5 valence electron. Look, carbon form 1 bond with hydrogen. Carbon can only make single bond with hydrogen and 3 bonds with nitrogen. Hydrogen cyanide. I told you, ignore this bond, ignore this bond. How the molecule looks to you guys? It looks like linear molecule. Visualize that one. It is like a linear molecule. Yeah. Linear. Bond angle 180 degree. Linear molecule. What's the shape? Linear. Bond angle 120 80 degree. Okay. Now, any more example for linear molecules? All they have double bonded and a triple bonded with no lone pair. Any compound which has double bond or a triple bond can be a trigonal planar or a linear. I will give you one more example, guys. Look at that. CH3, C double bond O, OH. This is ethanal aldehyde. Ethanal. ETHANAL. Ethanal, not ethanol, ethanal. It's an aldehyde. Look, each carbon make 1, 2, 3. I told you, ignore that double bond. So carbon has 3 bonded pair of electron and no lone pair. So what's the shape? Shape is trigonal planar. And bond angle 120. Look at that. So double bonded compound we have seen and triple bonded compound we have seen. Now some of the what we call some of the special categories, like they are not following a normal trend. So we do like not from the trend, like a trend mean like a group 4 element, group 5 element, group 6 element, and I have done the group 3 element, some specific shapes. Okay, I will come to shape of the ions. First, let me teach you all the molecules which I have seen those examples in many past papers. Yeah. Now, one more. Look at that. What is the shape and bond angle of PCl5? PCl3 we have discussed. PCl3, 1 lone pair, 3 bonded pair of electron. We've already discussed PCl3 when I have discussed group 5 elements. 1 lone pair and 3 bond pair, trigonal pyramidal. Now this is different one, PCl5. Now phosphorus has how many electron in the valence shell? 5. 1, 2, 3, 4, 5, and they all share with 5 chlorine. Do cross chlorine. That's okay, don't cross structure, but we can't predict the shape of the actual molecule and the bond angle. Now look at that. Look at that, guys. This is a planar trigonal, like this is a trigonal planar structure. Look at that. It's like this and like that one. Same thing, it's a planar structure. So I have phosphorus at the center. Look at that. This is phosphorus. P. It has 1 chlorine at the corner. Chlorine. There's a chlorine at the corner. We have chlorine. Look at that. At the corner, we have chlorines. So phosphorus, this is P, chlorine, 1 chlorine, 1 chlorine. Okay. Now, after that, it's like a planar molecule. How the 2 more chlorine oriented? Look at that. The 2 more chlorine is oriented like this, which is perpendicular to this plane. Look at that. So Actually, this is a 3D shape, and I can draw it, but you can't visualize from the board. So try to visualize that one. So it's the center one. I have phosphorus. That's the phosphorus. One chlorine, one chlorine, one chlorine. And the top we have one more chlorine, and the bottom we have one more chlorine. It looks like that. So I will try to draw it, how it will look like, and then we can visualize and find out the shape and the bond angle. Look at that. So this is trigonal planar compound, which is P chlorine, chlorine, chlorine. Now, two more chlorine, they are perpendicular. They are perpendicular. Look, chlorine and chlorine, they're perpendicular. Look at that. They are perpendicular. So, can you guess what is the shape of PCl5? Look, I try to tie some string here. I tie some string, and it looked like a pyramidal. Look at that. It looked like a pyramidal on the top, and one more pyramid at the bottom. So look that. Assume that we have a string and we hold it like this. So this is one pyramid from the top, and this is one pyramid from the bottom. So the shape is trigonal. This is trigonal bipyramidal, and it has two bond angles. Look at that. The bond angle, we know that bond angle. This bond angle is 120 degree, and that's the 90-degree bond angle. What's the 90-degree bond angle? That's a perpendicular. So what's the bond angle? 90 degree. So we have two bond angles. One bond angle is this one, which is 120, and this one is 90 degree, which is perpendicular. So that's the shape of PCl5. They can give you PBr5. So instead of chlorine, you can use any halogen. Phosphorus, possible. Do we have NCl5? No, not possible. We cannot have NCl5. Why we cannot have NCl5? Why there will be no compound such as NCl5? I will give you this as a question, so you have to figure out. There will be PCl5. There is a PCl5. All like 5 halogens are there for look at that. So phosphorus can form PCl5, PCl3 as well as PCl5. Phosphorus, arsenic can form ACl3 and PCl3 and all the halogen. Sb can form SbCl3 and SbCl3 and SbCl5, SbCl5, but not for nitrogen. Nitrogen cannot form pentachloride. There's no nitrogen pentachloride. But phosphorus can form pentachloride, arsenic can form pentachloride, bismuth antimony can form pentachloride. And what is the shape of the molecule? Trigonal bipyramidal, and it has two bond angle, 120 and 90 degree. Look at that, guys. Look at that. You can visualize like this. So what was the bond angle? What's the shape of the molecule? What is the shape of the molecule? So the shape is trigonal pyramidal, and the bond angle is we have two bond angle, 120 degree and 90 degree. Look at that. Shape of the molecule, shape of the molecule, molecule or compound, trigonal bipyramidal. And what's the bond angle? We have two bond angles, 120 degree bond angles, BA, 120 and 90. Okay, let's do one more compound, and that's one of the favorite compounds. My next compound is one of my favorite compound. Let's do that one. Look at that. That is SF6. So what is the shape and bond angle of SF6? Let's do the SF6 molecule. Shape and bond angle of SF6. What is the shape and bond angle of SF6? Sulfur hexafluoride. Sulfur can make 6 bond. No lone pair, all 6 bond. We can visualize from that. First of all, we have a square planar molecule, SF4, like square planar molecule. Look at that. This is square planar. I want to draw the square planar. Sulfur is here. We have fluorine. One fluorine and a fluorine. This is a square planar molecule. And a 2 more bond. One at the top, one bond coming from the top, F, and one bond from the bottom, F. So look at that. So that's the planar molecule. This is like a planar molecule. And we have one bond at the top and one bond at the bottom side. So how many faces it has? Look at that, guys. Please try to visualize. If you can't visualize, it's hard to memorize a compound. One bond here, 2 bond, 3 bond, 4 bond. 4 bond from the top and a 4 bond from the bottom. 1, a 2, a 3, a 4. So it has 8 faces. It has 8 faces, guys. Look at that. One face from that side. One face from that side. So one, this one, 2, 3 at the bottom, 4. In the same way, 1, 2, 3, 4. It looks like a complicated structure. It has 8 faces. So the molecule which has 8 faces, what will be its shape? The shape of the molecule is octahedral, like a tetrahedral. This is octahedral complex, SF6, or compound. SF6 is a octahedral molecule. Sorry, my bad, I use the term complex. We will do the complex when I will teach you transition metal. So we have different shape of the complexes also. So this is octahedral molecule. Now, can you let me know what's the bond angle? What is the bond angle? Look at that. What's the bond angle? Each corner, you know that each corner is 90 degree, 90 degree, 90 degree, 90 degree. One of the past paper question, give the example of a molecule having 90 degree bond angle. So 90 degree bond angle, 90 degree. You can get this kind of question also. What is the bond angle between this fluorine, sulfur, fluorine? What's the bond angle? 180 degree. Mostly they will ask what's the bond angle. You can mention 90 degree. If you will get a question specifically, what is the bond angle between sulfur, fluorine, and sulfur, then you can say 180 degree. Otherwise, that's fine. SF6 molecule. So instead of fluorine, can we take any other halogens? You can take SCl6, but I haven't seen SCl6 compound. SF6 is a common compound, a very famous compound. So the shape of the molecule is the shape of the molecule is octahedral and a bond angle is 90 degree. Okay, so I try to discuss all of the molecule which I came across from the different past paper. We have to do shape of the ions and some more specific example. So guys, I want to wind up my video here. I will come back with the next video. Thanks for watching.